Okay, so today we're going to talk a little bit about math, and you can see I have a z-score here. This z-score is going to take us back to what we did before. Quick reminder on when we had z-scores, we always said that our z-score, and connecting it also obviously to what we've done before, we always had like x minus the mean, the distance that you are from the mean, and then we would divide by the standard deviation. Well, I'm going to tell you today that you'll notice the slight difference here, but really the concept is the same. We're going to have a sample where our sample is going to be what we call p hat. That's going to be a sample. So that's vocab right there. When I say p hat, what I'm talking about is that I've taken a sample, let's say 100 people or 50 people. And this p is going to be the proportion of people that either answer yes or whatever we're looking for right here. Okay, so that's going to be the sample. Now, the standard deviation for that sample, okay, SE is what we call that. The standard deviation, we have a formula for that standard deviation. And it happens to be the square root of, you take the actual proportion, and we'll talk about that difference here in just a second, and then you multiply it times 1 minus p, okay? And then you divide by the total number of people in your sample. So really the best way to do this is to see an example of this. But before I do that, I do want to show you how that changes from here. We're going to be using a proportion to figure out if a sample proportion, okay, our sample proportion is different than our true proportion, which is just the P that you're seeing in this formula here on the sheet. So we have this P hat, my sample proportion, and I'm questioning how far away it is from my actual, like, given proportion. Okay, so that's the difference between a P hat and an actual proportion. And the formula for that is going to be, well, we find the distance that our sample proportion is from the true proportion, just like our sample from the true mean, same concept. And then we're going to divide by the standard deviation. Well, the standard deviation is this. You take your actual proportion times 1 minus p, because we're actually taking the standard deviation of the proportion, not our sample. We're just comparing our sample to the proportion, the actual proportion, and then you divide by the number of people. Okay, so we're going to do an example here to see what we do with all of this. It says, do you drink the cereal and milk? A USA Today poll asks a random sample of 1,012 US adults what they do with their milk in the bowl after they have eaten the cereal. We're going to let P hat, okay, P hat, be the proportion of people in the sample who drink their cereal milk. Okay, a spokesman claims that 70% of all US adults, so there's our actual p value. He claims that 70%, 0.7, 70% of people do drink their cereal milk. Well, our poll shows us that our sample proportion is actually just 67%. So we're going to be comparing these two things. So his claim is that 70% of people drink their milk, but when we took a poll of 1,012 adults, okay, my N is 1,012 adults, we had 67%. So ultimately what we're going to decide is, does this poll that we took, does that support the claim or not that he is saying? Or do I have reason to question this right here, this 70%? Because it looks like we got less than 70%. Okay, so we're going to complete a z-score here. This is the formula for z-score, and this is the one that you're going to end up using right here. We're going to take our sample proportion minus our actual proportion, or what they're claiming. They're claiming that it's 70%. I think it's less. And then we're going to divide by the standard deviation. So the standard deviation, I'm going to have to use this formula right here. So it's really just about, can you plug it into the formula here? So we use our p value, so 70% times 1 minus p, that's the probability that they don't drink their cereal. So that's the 30%. 1 minus 70% is 30%. And then divide by the 1,012 people that were in our study. Okay, so I'm going to break out my cell phone calculator so you guys can see exactly how I do this. I would put I'm going to do the standard deviation on the bottom first. I know that 67 minus 0.7, 67, 68, 69, 70%, right? This is a negative 0.03 or a negative 3%. So I know that top number. What I don't know is the bottom number here. So I'm going to do this in my calculator here. I'm going to do 0.7 times 0.3 first, and I'm going to hit enter. Then I'm going to divide it by the 1012 like that, and I'm going to hit enter. But then I need to take the square root of all of that. So I'm going to flip my phone and I'm going to hit square root and I get 0.12. I'm concerned here that I hit it twice. So let me do it again just to make sure. 0.7 times 0.3 divided by 1012. And then I flip it and I take the square root. Yeah, I must have hit it twice because that looked like a weird number to me. So I have 0.01. I could put 0.014 if I wanted to, but I kind of like to round everything here. So now what I'm going to do is to find my z-score. Okay, z-score, and we've done this a lot, so I'm kind of I'm going to go through that part fast. But I would take my 0.03 divided by 0.01, and I recognize that this is actually a negative, right? A negative, so I get a negative 3, a negative 3. Okay. The next stage when we had these right here was and this is again just a reminder and refresh on z-scores, we want to find how far away it is from that 70%. So our mean always goes in the middle. So it's not a mean this time, it's a proportion, but it's that same concept. We got a standard deviation that was 3 way out here. So 67% is way out here. And that's only going to happen, like my z-score is negative 3. If you remember, that's like at the very, very tail end, okay? In fact, just to show you guys where the z-scores are, the z-score table I linked again at the very top of this module right here. When you go to it, it won't show up in here. So what you're gonna have to do is actually click on the link and it will take you to that link for the z-score. So now when I look up negative 3, that's negative 3.0, that is my proportion, 0.0013. That's the area to the left. This is going to happen less than 1% of the time. If I think of it this way, it's actually 0.1% of the time I would get a sample of 0.67. Okay, or you could say 67%. Okay, this is rare. Okay, if you remember, anything less than 5% of the time is going to be deemed rare. Okay, if we get a rare result, then we know we have enough evidence. Okay, we have enough evidence to say that less than 70%, okay, because they claimed that 70%, let me remember the context here for a second. Let me go back to lesson 1, 16, module 16. Lesson 1. So less than 70%, because they were claiming 70%. We didn't think that that was true. We thought it was less than. If it happens less than 5% of the time, then we deem those rare and we say that there is enough evidence to suggest that less than 70% drink their milk. Had I only gotten like one standard deviation away, and this happened more than 5% of the time, like it happened 10% of the time, then I would say that, nope, this sticks, it's 70%. Okay, but because we got something that happened too rare, we're going to actually say, you know what? No, they're incorrect. It definitely happens less than 70% of the time. It's not 67 necessarily, but it definitely happens less than 70% of the time. Okay, so that shows you an example. You have three homework problems tonight. So you'll be looking at one, two, and three, and you're doing that same exact thing every time. So you're going through, you have a sample proportion, a true proportion, and then you're using that to figure out the Z score and whether or not it's rare enough. Okay, so that's going to be the process. I have a video at the bottom of this that will show you how I go through each one of these if you need help.